Nomenclature. It is important to be able to name compounds like NaCl, CO2, or CaCl2, both in the field of chemistry and in normal life. One good example, however silly, is about two chemists who go order drinks at a restaurant. One orders H2O, while the other orders H2O too. The second chemist then dies from drinking hydrogen peroxide. While the rules for naming compounds can get quite complex when going into organic and inorganic compounds, and some molecules like water are known more by their common names, we will only look at the simple molecules and their scientific names. The compounds we will look at can be separated into these two categories, ionic and covalent. There are several important differences between ionic and covalent compounds, but for now, just remember that ionic compounds are nonmetal atoms taking electrons from metal atoms, while covalent are between nonmetals sharing electrons. Covalent compounds. When naming covalent compounds, it is important to look at the compound to decide what becomes the first half of the name. This is because both types of atoms are anions. For example, CO. The formula for CO begins with a carbon, so that is what we will write out first. Next, look at the second type of atom. Erase the ending of its name and add an "ide" as a suffix. Due to the nature of covalent compounds, compounds like CO and CO2 would have the same carbon oxide name. So there's another way of naming covalent compounds to differentiate them. When looking at covalent compounds, you number the number of atoms with prefixes like mono, di, tri, etc. However, on the first half of the name, the mono is not used. So a compound like CO would be carbon monoxide and CO2 is carbon dioxide. Another example would be O2F2. Oxygen is written first, but this time there is more than one, so it'd be dioxygen. Then write fluorine, add a di, erase the "ine", and add "ide". Ionic compounds. When naming ionic compounds like CaCl2, first you must know what atoms make up the formula unit. We can see that there is a calcium atom and two chlorine atoms bonded. Now that we know what makes it up, the next step is to decide which atom gets to come first in the name. In ionic compounds, the cation, the positive ion, comes first. An easy way to remember this is that you need to start out positive, or you can just see that the cation always comes first in the formula. Now that you have found which atom goes first in the name, write it out. In this case, we write calcium. After we have this, we need to figure out what to do with the chlorine atoms, our anion. This is similar to what we do with covalent compounds. You just write out the atom's name, erase the ending, and add "ide" instead. In covalent compounds, the number of atoms bonded can be different, like CO and CO2. However, this does not happen with ionic compounds. The number of atoms that can bond together is more strict, so prefixes are not needed to understand that calcium chloride is CaCl2. While this is the naming method for some ionic compounds, there is a slight difference with transition metals. While some metals have only one oxidation state, which is just another way of describing the charge, some metals have multiple oxidation states. These metals are mostly transition metals like iron, tin, and copper. Iron, for example, could have a charge of +2 or +3, so seeing the name iron fluoride could be FeF2 or FeF3. In this case, we need to add a way to distinguish this. Chemists have decided that the best way to fix this problem was to include the charge of the cation by placing the charge between the cation and anion. Roman numerals are used to show the difference. So instead of iron fluoride, the name could read iron 2 fluoride. Polyatomic ions. All of the examples so far have been binary compounds, meaning there are only two different types of atoms that make up the compound. However, ionic compounds can have more than just two types of atoms. Instead of a single atom making up an anion or a cation, there can be multiple atoms. Some examples include NaNO3, BeSO3, and NH4Cl. The polyatomic ions, in this case the NO3, SO3, and NH4, have specific names while alone: nitrate, sulfite, and ammonium. The name of each polyatomic ion is different, and some ions have similar names, such as SO3 and SO4, which are sulfite and sulfate. When you have two polyatomic ions with similar components, the one with the most amount of atoms typically has the suffix -ate. For the most part, anions end with -ide, -ite, or -ate, while cations do not have a naming pattern. When naming compounds with polyatomic ions, you name the same way as with binary ionic compounds, except with a different ending for the anion. In the case of NH4Cl, the compound is read as ammonium chloride. NaNO3 is sodium nitrate, and BeSO3 is beryllium sulfite. So, when naming with polyatomic ions, the polyatomic ion's name never changes.